All right, let's dive right into this explainer. Welcome, everyone. So today we are tackling a really massive challenge in the AI space. Picture this. You've written an absolutely incredible AI agent. It works perfectly on your local machine, it's fast, it's smart. And then you show it to a second person, and the whole thing just crashes. Boom. But how do you actually take it from a basic, single-user script and scale it up into a robust, multi-tenant application? One that can handle real-world traffic without breaking a sweat? Well, that is exactly what we're unpacking today as we look at Agent Service, the really powerful hosting layer for AgentScope.
Here's our quick roadmap for today. We'll start with moving from scripts to production, look at the core capabilities unlocked, explain the resource model, talk about customizing the service, peek under the hood, and finally go over deploying your very first agent.
Okay, part one. From scripts to production. We're talking about that big leap from local environments to scalable HTTP services.
I really want you to ask yourself this exact question. How do you take an AI agent from a local script to a production service? Seriously, think about it for a second. A local script is built for one person. It's totally safe and cozy on your laptop. But production? Production means multiple users, concurrent requests coming in all at once, and totally unexpected delays. You can't just throw a simple Python script onto a server and magically expect it to handle hundreds of people asking complex questions at the exact same time. It just doesn't work that way. Think about the sharp contrast between those two environments. A local agent script has a single user, the memory completely disappears the second you close your terminal, and if a tool takes 5 minutes to run, your whole program just freezes. It's blocked. Agent Service completely solves this by stepping in with a FastAPI-based hosting layer. It basically wraps your agent into a multi-tenant, persistent, and asynchronous HTTP service. And honestly, the best part, it completely owns the request routing, the session state, and the persistence, so you don't have to rewrite your core agent code just to make it web ready.
Moving into part two, core capabilities unlocked. Let's look at what actually sets the agent service apart when you get into production. It's fascinating how specific developer headaches map directly to built-in solutions here. For instance, if your agent needs to go off and scrape some massive website, your user shouldn't be sitting there staring at a frozen chat screen, right? To fix that, Agent Service introduces background task offloading. It literally moves that heavy lifting to the background and streams the results back when it's done without blocking the ongoing conversation. Need recurring tasks? Bam, built-in cron scheduling. Need to make sure users can't snoop on each other's files? You've got pluggable workspace management. It is just a highly robust, thought-out toolkit.
Now, this has to be one of my absolute favorite features, session replay. Have you ever been using something like ChatGPT, refreshed your browser window by accident, and completely lost the stream of text that was actively generating? It's so frustrating. Well, Agent Service solves this at the architectural level. By using a per-session server-sent event stream, any late joining client automatically gets the buffered history before the live events kick in. So whether your user refreshes the page, briefly drops their cell connection, or opens a second tab on their computer, the front end stays perfectly in sync. It is a massive, massive win for user experience.
All right, part three. The resource model explained. Time to unpack the underlying architecture and its boundaries.
If you take exactly one architectural concept away from this explainer today, absolutely make it this distinction. You have to separate the agent from the session. Think of the agent as your blueprint. It's the reusable identity, the display name, the system prompt, the baseline configuration. The session, on the other hand, is the runtime state. It's the actual living conversation you are having right now. It holds the working memory, the in-flight replies, and the specific LLM model selected for that exact chat. One single agent template can drive thousands of unique, totally isolated sessions.
To actually pull off multi-tenancy safely, every single operation in the system is strictly bounded by a user ID. So isolation is a built-in reality from day one, not some afterthought. You also have reusable credentials for securely handling API keys, workspaces for strict file isolation, and schedules for running those cron jobs. And tying all of these persistent resources together dynamically, that's the message bus, a Redis-backed runtime layer that expertly handles the routing of all these events.
So how does this actually flow in practice? It's incredibly logical. Step 1, you create the agent, defining its core identity and instructions. Step 2, you configure a credential, safely storing your provider's API key. Step 3, you create a session, basically marrying that agent template to a live runtime state and model configuration. And finally, step 4, you just start chatting by posting to the chat endpoint and subscribing to that event stream. It's a very clean, progressive lifecycle that keeps your entire production environment predictable.
Let's move to part 4, customizing the service.
how to adapt AgentScope to your specific infrastructure.
You know, agent service is remarkably flexible. For example, out of the box, it ships with a simple X user ID header for quick development, but you can effortlessly swap that out for secure JWT or OAuth authentication when you move to production. You can adapt the native streaming protocol to external formats like AgentUI. You can change your workspaces from local folders to Docker containers or even E2B sandboxes. You can even replace the default Redis storage backend with Postgres if you want. You literally aren't locked into anything.
I absolutely love this quote straight from their documentation. Open at the boundary, swappable without touching framework code. Honestly, that is the golden rule of scalable software architecture. You can completely transform how the service authenticates users, how it stores data, and how it executes code, all by plugging into well-defined boundaries rather than awkwardly hacking apart the core framework itself.
Adding a new LLM provider is beautifully simple. It's as easy as dropping a YAML file into a directory. This YAML file basically acts as a declarative model card. It tells the entire system what MIME types the model accepts, its maximum context size, and it provides a declarative JSON schema for request inputs. Because it's schema-driven like this, your front-end UIs can dynamically render configuration forms and capability badges without you ever having to hardcode provider-specific logic into your application. It's so clean.
Section 5. Under the hood. Let's look at how this FastAPI application is actually wired together. Deep inside the application state, several core managers handle the heavy lifting. The absolute most critical one is the message bus, which acts as the central nervous system. It manages Redis primitives, inbox queues, and session locks. And why is this so important? Well, because when a background task finishes or a scheduled cron job fires off via the scheduler manager, they don't just talk directly to the agent. No, they drop a message on the bus. Then the wake-up dispatcher sees the signal, wakes up the idle session, and hands it straight off to the chat service to process the new information.
Now, intercepting these actions behind the scenes are the agent-level middlewares. Think of them as your safety nets. The inbox middleware seamlessly injects those background tool results into the agent's context right before it starts reasoning. The tool offload middleware is the vital safety net that actively grabs long-running tools and pushes them to background tasks so things don't freeze. And the state change middleware ensures that anytime the agent's internal memory or task context shifts, a custom event is emitted so your front-end UI updates in real time.
Because all these internal dependencies heavily rely on each other, the service has a very strict lifespan execution order when booting up. It starts the storage, then the message bus, then the workspace manager, and finally the chat service. And crucially, it tears down in the exact reverse order when shutting down. This is what ensures absolute data safety and state integrity, meaning absolutely no active chats get dropped before their state is safely persisted to storage. Finally, Part 6. Deploying your first agent. How you can get started in just a few minutes.
You can seriously get a production-ready environment running locally in minutes. First, clone the AgentScope repository. Second, just make sure you have a local Redis instance running and reachable. Third, fire up the example Python backend, which defaults to port 8000. And finally, start the bundled example React frontend. That's it, you're up and running.
And I have to say, this bundled UI is way more than just a basic Hello World screen. The example playground gives you an immediate, highly visual sandbox to test out these advanced multi-tenant features. You can click around to test permission controls, literally watch background tasks stream in asynchronously, observe the agent mapping out complex task plans, and even spawn full agent teams. And you do all of this without writing a single line of new code. It perfectly and visually proves the backend architecture we were just talking about.
So I want to leave you with this final provocative thought. Is your agent actually ready for production? We've seen today exactly how Agent Service takes all the fragility out of those local scripts by wrapping them in a scalable, async, multi-tenant architecture. With powerful features like session replay, background offloading, and totally pluggable boundaries, the tooling is 100% there. Now, it's up to you to build something incredible with it. Thanks so much for joining me on this explainer, and happy building.